Okay, hello everyone. Today we are going to talk about cerebrum, which is the largest and the most conspicuous part of the human body. I am Dr. Sudakshina. So, as you know that cerebrum controls a lot of higher mental functions. It is also very important for intellectual functions, judgment, memory, and it is also very important for visual activity and also auditory functions, smell, taste, speech, etc. So you have I have shown you in my first slide itself that you have the four lobes of the cerebrum, and you can see here I have labeled out the four lobes, that is the frontal lobe, the temporal lobe, the parietal lobe, and the occipital lobe. And the most important functions of these lobes, like frontal lobe is more of planning, judgment, thinking, memory, whereas the temporal lobe is associated with definitely memories, hearing, smell. Okay, and then we have the parietal lobe, which is associated with a lot of perceptions of sensory sensations like touch, smell, taste, etc. And visual lobe is primarily concerned with vision. It is like dedicated for vision. Okay, so it's a very colorful part of the brain, it's a very conspicuous part of the brain. So let's proceed. Okay, so coming to the learning objectives. So a student should be able to describe the general structure of the cerebrum and the cerebral cortex. You should be able to identify the cerebrum and the lobes of the cerebrum, major divisions, and able to describe the primary functions of the lobe and the cortical areas of the brain. So let's go to the next slide. So let's see, it's like a preview. So it's the largest part, I have already told you, and it has two cerebral hemispheres, and both the hemispheres are connected with each other by the corpus, by a band of white matter, which is the corpus callosum, which will be a later class. Okay, so the surface actually shows elevations, which are called the gyri, and separated by depressions, which are called the sulci. So you can see a sulci and gyri. Each hemisphere is divided into four lobes by deeper grooves. So the hemispheres, each cerebral hemisphere is divided into deeper grooves into four lobes, and these deeper grooves are also called fissures, and the lobes are separated by deep grooves, and that's what I'm saying, it is also called the fissures. Okay, let's see. In the first slide you can see the cerebrum has two cerebral hemispheres, and it is separated from each other by a longitudinal fissure or a median longitudinal fissure. Okay, so now here I want to clarify one thing. Whenever we are talking about the cortex, it is the outer part or the outer gray matter of the cerebrum. So here the gray matter is outside or the superficial, and the white matter is in the center of the cerebrum. So cortex is nothing but, cerebral cortex is nothing but the outer gray matter. Okay, so now let's see the surfaces of the cerebral hemispheres. So each cerebral hemisphere has three surfaces. You have a superior lateral surface, okay, and then a medial surface and an inferior surface. Inferior surface is again divided into an orbital and a tentoral surface. So what you can see over here is nothing but the superior lateral surface, and we are going to come to the superior lateral surface more clearly in this slide. So you can see on the left side we have the superior lateral surface, whereas on the right side we are showing you the medial surface. And as you concentrate on the medial surface, you can see in the center of the medial surface you have a corpus callosum, which is going to connect both the cerebral hemispheres, and you have some bold lines which are nothing but the fissures or the sulci, and some areas in between are called the gyri. So we will come to that soon, what are the sulci and what are the major gyri we are having in the cerebrum. Okay, so we go through the other surfaces. So we have another surface which is the inferior surface. Here you can see clearly the inferior surface, and in the red it is written the anterior part of the inferior surface is the orbital surface, and the posterior part of the inferior surface is also called the tentoral surface. Okay, so and then you have on the orbital surface we also can see the olfactory bulb, which is seen in the center. Okay, so this completes the surfaces of the cerebrum. Now coming to the borders of the cerebrum, again we have three borders. Already we have seen the median longitudinal border fissure, which is nothing but the superior medial border excuse me, of the cerebral hemisphere. And then we have two inferior border, one inferior lateral border and the inferior medial border. So these are the borders, and for the borders and the surfaces you will get more clear if you follow the video which I have already uploaded for the on the gross anatomy, gross specimen video. So then you can understand better. But this is for completion's sake. We have to talk. You have to write in your theory papers. Okay. So let's see the poles of the cerebrum. So what are the poles? There are 3 poles you have to remember. So 3 surfaces we have talked about, and now we are talking about the 3 poles. That is the frontal pole, which is anteriorly placed. Then we have the anterior inferior, you have the temporal pole, and you also have posteriorly the occipital pole. So just below the occipital pole you can see the cerebellum very clearly. So these are the poles of the cerebrum. Now coming to the lobes of the cerebrum. So cerebrum has clearly 4 lobes. So it has been classified. 4 lobes are clearly seen, whereas we also have something sometimes we call like a 5th lobe is the insula, which lies very deep. It lies deep. It's not seen on the surface. It lies deep to the lateral sulcus. So how this lobation of the cerebrum is possible? It is only possible through the main fissures. So the most important fissures are very important to know, the fissures which actually divides the cerebrum into 4 lobes. So what are the 4 lobes? We have the frontal lobe, which is in blue. You can see over here, and the green is the parietal lobe, and you have the orange or the peach color is the temporal lobe, and more orangish pink is the occipital lobe. So it is seen very clearly. So let us see how do we divide the cerebrum into 4 lobes. Clearly main 4 lobes. Okay, so you have a fissure over here which is actually called the fissure of Rolando. You can see that it is coming down vertically from the superior medial border, and it is coming down, and more or less it is coming very close to the fissure of Sylvius or the Sylvian fissure. It is also called the lateral sulcus. Fissure of Rolando is also called the central sulcus, and the part of the cerebrum which is in front of the fissure of Rolando or the central sulcus is the frontal lobe. And you can see over here the fissure of Sylvius that has 3 parts. It has an anterior ascending ramus, anterior horizontal ramus, and the posterior ramus, which is actually cutting across the cerebrum. So you can see over here cerebral superior lateral surface of the cerebrum horizontally, and there is also a dotted line after the fissure of Sylvius, which starts to turn upwards. So from the point it starts to turn upwards, we have drawn a dotted line, and this line goes and meets another imaginary line which is drawn from the parieto-occipital fissure, from the end point of the parieto-occipital fissure to the pre-occipital notch. Now this pre-occipital notch is about 4 to 5 centimeters anterior to the occipital pole on the inferior lateral border. Okay, so these are the imaginary lines which are drawn, nothing but extensions of these major fissures, and so that we get 4 well demarcated areas, and so that we get the 4 lobes. So the frontal lobe is anterior to the fissure of Rolando or the central sulcus, behind the central sulcus, above the lateral sulcus or the fissure of Sylvian, and in front of the parieto-occipital fissure you get the parietal lobe. Below the fissure of Sylvius you get the temporal lobe, and behind this imaginary line from the parieto-occipital fissure to the pre-occipital notch you get the occipital lobe. So this is how we have divided the cerebrum into 4 major lobes. Now there is another lobe which lies deep to the fissure of Sylvius. So deep to the fissure of Sylvius, you can, if you retract the fissure of Sylvius, you can see a structure deep to the fissure of Sylvius which is called the insula. Okay, so that is also called the 5th lobe. Okay, so next is we are talking about this sulcus and this gyri. So always remember the gyri are nothing but a complex pattern of convolutions, whereas the sulci are furrows, or they are of varying length. They are like fissures. And why there's so much of convolutions? Because the convolutions and the sulci and gyri is a very characteristic feature of human brain. And what they do, they increase the surface area. Because the surface area is increased, so the cortex, the cerebral cortex, can accommodate a large amount of gray matter. Gray matter is nothing but neurons, or the cell bodies of neurons. Okay, and the white matters are the connecting fibers. So it actually accommodates a large amount of neurons, which is very important for human brain, which is one of the most complex structures. Okay, so what is the surface area of cerebral cortex? It is about 2200 centimeters square. So that's the reason it has so much of convolutions. Okay, so now coming to the importance sulci and gyri, we already have talked about some of the important sulci and gyri. To lobate, to create the lobes of the, to demarcate the lobes of the cerebrum. So here it's one of the important sulci is the lateral sulcus or the Sylvian fissure. You can see over here it is marked. So I told you it actually starts somewhere from the medial surface and it comes to the superior lateral surface and it continues as three branches. So it has three rami: anterior horizontal rami, anterior ascending rami, and posterior ramus, which continues backwards. And so this is kind of horizontally cutting across the superior lateral surface, the posterior ramus. So this is called the lateral sulcus or the Sylvian fissure. Okay, and the floor of this posterior ramus, you have to remember that you have the insular cortex or the insula, which is the hidden cortex. Okay, so now let's go to the another sulcus on the superior lateral surface, which is the central sulcus. So if you see the central sulcus somewhere starts from the superior medial border. Actually it is starting from the medial surface, it cuts across the superior medial border and comes vertically down on the superior lateral surface and comes very near to the posterior ramus of the lateral sulcus and ends very near to the posterior ramus of the lateral sulcus. Okay, so it's yes, so the other sulci what we are getting, definitely the central sulcus is also called a limiting sulcus because it lies between the sensory between the motor cortex which lies anterior to it and the sensory cortex which lies posterior to it. So it is called also a limiting sulcus. Okay, so now coming to the next, the other sulci, you have the superior frontal sulcus, inferior frontal sulcus. These are all in the frontal pole lobe, and then the precentral sulcus, the postcentral sulcus, which precentral sulcus is in the frontal lobe, postcentral sulcus comes in the parietal lobe, and these are all demarcating the premotor cortex and the sensory cortex. Okay. So now coming to the medial surface, the most important sulcus over here has been shown. Already we have talked about it, is the parieto-occipital sulcus, which actually starts a little below the splenium of the corpus callosum. It branches upwards and it goes upwards, and another sulci which actually curves and goes downwards. It has a convexity towards the superior medial border, and that sulci is called the calcarean sulcus, which is very important because the visual cortex is lies in the calcarean sulcus. So and then you are having also the on the medial surface another sulcus which is actually following the curve of the corpus callosum, which is called the cingulate sulcus, and cingulate sulcus gives an offshoot and then it is coming and ending behind the central sulcus. You can see the starting of the central sulcus from this medial surface. You can see over here the central sulcus is starting from this blue area, and so the cingulate sulcus is giving an offshoot just before the central sulcus, and this area between the ending of the cingulate sulcus and this offshoot is called the paracentral lobule. It is very important because this area is associated with lot of sensations which are received from the perineum and the also the fingers and some of the limbs. Okay, so finer movement and also from the perineum, and also the motor cortex, as you can see it is marked in the blue. So motor area, so that is also coming and ending over here, and the pink area which is actually the motor cortex is also coming and ending over here. So this is actually the paracentral lobule. Okay, so you can see here also the parieto-occipital sulcus. So the area between the parieto-occipital sulcus and the calcarine sulcus. So this part of a triangular area what we are seeing between the calcarine sulcus, which is convex upwards, and the parieto-occipital sulcus, this area is called the, which is in light yellow, which is called the cuneus, and in front of the parieto-occipital sulcus till the ending of the cingulate sulcus, that area is also called the precuneus. Okay, so let's see some of the sulci on the inferior surface also. Some actually this collateral sulcus falls on the inferior surface, but we can see it over here. You can see over here the collateral sulcus. Okay, and then so these are some of the important sulci in the medial surface. So let's continue. Okay, the posterior region of the medial surface, we have already seen the parieto-occipital and the calcarine sulcus. In the inferior surface, we can see the collateral sulcus, which we have shown you, olfactory sulcus, occipitotemporal sulcus. So some of the important sulcus. Now most important thing is visual cortex lies above and below the calcarine sulcus, which I have shown you in dark yellow color. Okay. So next slide, we are going into the insula. We have talked about the insula, which is lying on the, when we retract the lateral fissure, that is the, or the lateral sulcus, the lips of the lateral sulcus, we are going to see a hidden cortex, which is nothing but the insula. So you can see over here the insula. Sometimes it is considered as the fifth lobe of the cerebrum. The overlying cortical areas are called opercula, which are formed from the parts of the frontal, temporal and parietal lobes. So operculas are actually covering this this insula, and insula is linked to emotions and body homeostasis, perception, self-awareness, cognitive function, interpersonal experiences. So it has some complex functions. Okay, now coming to the inferior surface. So in inferior surface, you can see that we have divided the inferior surface into orbital and tentoral surface, and some of the important sulci we are able to see is the orbital sulcus and the orbital gyrus on the top. So you can see over here, so some of the important sulcus, that is the orbital sulcus. Okay, and then we are also seeing the orbital gyrus recti. Olfactory sulcus is also seen when we have retracted the olfactory bulb. Onto the other side, we can see the olfactory sulcus in the anterior part, and here we can see a decussation, that is in the midline, that is the optic nerve decussation. Okay, and then as we go backwards, we have the most important, the tentorial part, and you can see over here the demarcation of the lobes are shown. So you have this temporal lobe, which is shown in the dark gray, and then the green color is the occipital lobe. So these are the demarcations of the lobes in the inferior surface, and definitely you will be seeing a very important sulcus over here is the collateral sulcus and the occipitotemporal sulcus. Okay. Let's go to the next slide. So now we are coming to the very important functional areas or the Brodmann areas. If you see, even in physiology, these areas are important. So we have only considered the most important Brodmann areas. So if you see over here, this is the on the left side, you are seeing the superior lateral surface of the brain, in which you have the area number 4, the central sulcus is seen, and in front of the central sulcus is the green color with dots is the area number 4 or the primary motor cortex. Behind the central sulcus, you have a light blue color or sea green color area, which is the primary somatosensory cortex or 321, area number 321. Area number 4 is the primary motor cortex. Okay, and then you have something on the frontal lobe, you can see over here orange color and yellow color, and that is the area number 44-45, which is the motor speech area or the Broca's area. And you can see in the temporal lobe, that is area number 22, which is the primary auditory cortex, and areas number 39-40, which is in the parietal lobe, you are getting the Wernicke's area or the sensory speech area. And then obviously you have the primary visual cortex, which is area number 17. 17 is the primary visual and secondary visual cortex is 18. So these are all in the superior lateral surface. If you continue it in the medial surface, you can see the paracentral lobule area, which I have described. It is actually is having the continuation of the motor cortex anteriorly, and posteriorly you have the continuation of sensory cortex, and the central sulcus is kind of beginning from here. And this part is very important for sensations from the perineum, and also from the, because the representations also from the fingers, and representation of these areas are more in the sensory and motor cortex because of the more number of neurons are representing these areas, that is the perineum and the fingers, because of more amount of motor activities. Okay, So let's see this over here. So you can see here very well it is represented how the motor homunculus and the sensory homunculus is represented. So you can see over here you have anteriorly the motor cortex. This is the central sulcus which has been labeled, and posteriorly the blue color is the sensory cortex, and it is inverted representation. You have the tongue, lips, face which is inverted, which is represented below, whereas the wrist, hand, elbow, feet, all these are going above, and this is continuous with the paracentral lobule on the medial surface. Here again in orange you can see the Broca's area, which is the motor speech area. Auditory area is in the temporal lobe. It is more or less associated with hearing, and it is yellow colored area. And then you can see over here green colored visual cortex, which is very important in your occipital lobe. So occipital lobe is more or less dedicated to visual sensations, so visual cortex, so it's very important. Okay, now coming to the frontal lobe and some of the most important areas, again I am kind of stressing upon. So you have the central sulcus, and you have the primary motor cortex which is drawn in the dark blue, and the Broca's area is the motor speech area, and in front of that you have the light blue, that is the frontal lobe, which is associated with other functions like you have the more important for intellectual functions, judgment, memory, short-term memory. All those things are associated more with the anterior part of the frontal lobe. So you can see these are the main importance of the frontal lobe. Okay, so we are going into the next slides. Okay, parietal lobe. So you can see the parietal lobe, you have the green color which is the primary somatosensory area number 312, which is very important for sensations, okay, for tactile and proprioceptive sensations which are picked up. Somatosensory association area you can see just behind in light green. This is the associated area, that is area number 7. And this is associated with assist in integration and interpretations of sensations relative to the body position and orientation in space, and also assists with visuomotor coordination. So that is also very important. And you have a gustatory cortex, that is the area number 40, just above the posterior ramus of the lateral sulcus, and it is associated with taste sensation. So gustatory cortex, you can see all these things, all these sensations are actually forms a very important functional component of parietal lobe. Okay, coming to the occipital region, which is purely dedicated to vision. So you have the primary visual cortex, area number 17, in dark maroon, and you have the bright red, which is the visual association area, which interprets the information acquired through the visual cortex, and which is in bright red. Now this is a very important part, because the occipital lobe is only associated with vision. It is like purely it is kind of purely dedicated to vision. Okay, so next let's go to the next slide. Yes, so now we are coming to the blood supply of the cerebrum. Now blood supply of the cerebrum is very important, and you have to understand this master diagram. This is showing the anterior circulation and the posterior circulation of the entire brain. Already you know some of the vessels over here. You can see in the posterior circulation we have talked about the vertebral artery, the branches of vertebral artery which are supplying the medulla oblongata. Then we have told that the vertebral artery will join together and form the basilar artery at the pontomedullary junction, and the basilar artery will run in the basilar groove of the pons, ventral surface of the pons, and then at the superior border of the pons it is getting divided, and it is giving rise to the posterior cerebral artery. So you can see that. So this is actually contributing to the posterior circulation. Now what about the anterior circulation? Anterior circulation of the brain is mainly from the internal carotid artery, which is shown over here. You can see over here internal carotid artery, and internal carotid artery enters, and then what happens to it? It gives rise to some of the branches. So it gives rise to a communicating branch, posterior communicating branch, which goes and joins the posterior cerebral artery, and it also gives rise to the anterior cerebral artery, gives rise to anterior choroidal artery, and these arteries are interconnecting with each other. At least anatomically they are interconnecting, may not be physiologically interconnecting and with each other to form a circular structure which is called the circle of Wills. You can see the anterior, the posterior communicating artery, the posterior cerebral artery, and it is also giving rise to a very big artery which is called the middle cerebral artery. You can see over here the internal carotid artery gives rise to the middle cerebral artery, the anterior cerebral artery, and also the posterior communicating artery. So the cerebrum is actually being supplied by posterior cerebral artery, anterior cerebral artery, and middle cerebral artery. So posterior cerebral artery are nothing but the two divided branches of the, or two formative branches from the basilar artery, which is from the posterior circulation, whereas anterior cerebral and middle cerebral are coming from the internal carotid artery. To make you understand this, I have shown this diagram, and it is a master diagram because blood supply of brain is extremely important question for you. You can see over here the anterior cerebral arteries are interconnected with the anterior communicating artery also. Okay. So now let's see exactly what part of the cerebrum is supplied by which artery. So whenever we are talking about the blood supply, you have to draw the diagrams. Now you can see over here, this is the medial surface. So we are talking in surface wise, the blood supply. So medial surface of the cerebrum is primarily supplied by the anterior cerebral artery. You can see this whole blue color, it is mainly by the anterior cerebral artery. Very little part of the temporal lobe, you can see over here, yellow color, is supplied by the posterior cerebral artery, whereas very little part of the temporal pole is supplied by the middle cerebral artery. Okay, so you can see over here it is mainly the anterior cerebral. So what are the cortical branches of the anterior cerebral artery? So you have the orbitofrontal, you have the frontopolar, you have the callosomarginal, callosal branches which will supply the corpus callosum. So all these branches are cortical branches. There are some central branches also which will go deep and supply. So when we see the circle of Wills, you can see over here. So this anterior cerebral artery, middle cerebral artery, and posterior cerebral artery mainly gives rise to superficial branches or cortical branches, whereas the deep part of the cerebrum, that is the white matter, will be supplied by these small branches which are called the striate branches or deep branches, which are going into the from the circle of Wills, from this circle. Okay, so these branches which are going, these are also called the perforating branches. Okay, and they will be supplying the white matter. Okay, now let's see the cortical branches from the posterior cerebral artery, which actually supplies the lower part of the medial surface, and these are more of occipitotemporal branches and temporal branches. Calcarine artery which is coming from the posterior cerebral artery, run in the calcarine fissure. Parieto-occipital artery which runs in the parieto-occipital fissure. So these are the cortical branches which are coming from the posterior cerebral artery and supplying the medial surface. Okay, so now let's go to the superior lateral surface. Now I have labeled the superior lateral surface as the red color. You can see over here, this is primarily supplied by the middle cerebral artery, whereas in medial surface we saw primarily supplied by the anterior cerebral artery. The superior lateral surface is primarily supplied by the cortical branches from the middle cerebral artery, whereas near the superior medial border till the parietal lobe, it is supplied little bit by the anterior cerebral artery, and the posterior, that is the occipital lobe, and also a little bit strip of the inferior part of this superior lateral surface is supplied by the posterior cortical branches of posterior cerebral artery. So you have to demarcate and draw these diagrams when the blood supply of cerebrum or cerebral cortex is asked. Okay, now next let's see the comparison. So here you can appreciate the inferior surface. So we have not talked about the inferior surface. So this shows the inferior surface of the cerebrum and how the blood supply. So inferior surface is again primarily supplied by the posterior cerebral artery. So one surface is dedicated to one artery. So inferior surface mainly by posterior cerebral artery. Anterior part of the inferior surface or the orbital part is supplied by the middle cerebral artery, whereas a very small strip towards the median plane, it is supplied by the anterior cerebral artery. So for the superior lateral surface, it is primarily by the middle cerebral artery, whereas the medial surface you are seeing primarily by the anterior cerebral artery, and the inferior surface is primarily by the posterior cerebral artery. So this is very important diagram. You have to draw this diagram and explain the blood supply of the cerebral cortex. Okay, so now coming to a very short recap, you have to know about the borders, lobes, border surfaces of the cerebrum. Next, definitely the prominent sulci and the gyri to differentiate the borders, to differentiate the lobes of the cerebrum, and also important functional areas. And also we have to talk about the blood supply of the cerebral cortex for a recap. Okay, so now thank you for listening to this, and next we'll be coming up with the white matter of the cerebrum. So this actually gives you an introduction to cerebrum and the cerebral cortex and its blood supply, and definitely the lobes, the poles, and the major sulci, major gyri, and also the very important other functional areas which you have to know even from the physiology point of view.